Hi. Welcome to Top Ways to Deliver Your Java Code to the Cloud. My name is BEnz. I am from Microsoft. I am a cloud developer advocate. And it's my job to reach out to the Java community and share what we've built, and also then get feedback from the Java community about what we're doing right and what we could do better. So that's kind of what we're doing. Let's give it a couple of minutes actually till the crowd files in. In case anyone's wondering on the recording, that background noise is a drum team out there who's having a lot of fun. So, all right. So as I was mentioning, my name is BEnz. I'm a cloud developer advocate at Microsoft, and today I'm going to talk about top ways to deliver your Java code to the cloud. Please do follow and feel free to live tweet, and then we talk about today. So thanks for coming. So let's see. I'm just going to talk about platform and deployment options, and I'm going to specifically talk about virtual machines, containers, and some software as a service offerings that we have specific and unique to Microsoft. But all the stuff that I'm going to talk about today is open source. It's all on GitHub, and could be used on any cloud, theoretically. Obviously, I'm going to show Azure because I work for Microsoft. So, but I'm also going to show some SDKs and tools that we built to work with our services, and some more resources. So let me ask you, how many people here have Java code on the cloud now? One person? Okay. And so you're basically all mostly on-premise, I assume, so you've got some Java code out there. Do you use virtual machines on-prem? Okay, so at work you probably use virtual machines. And okay, so I'm going to talk about virtual machines in my first demo. I'll show you that, so don't worry about that. I'll talk briefly about containers then. I like to get a feel for what people are doing. How many people use containers now? Docker? Okay, just a couple? Okay, so I'll touch on containers, but probably won't go into a lot of depth on those. So I'm going to show you how to deploy things. I think I'll do a VM demo, and then something that deploys from Eclipse directly to what we call web apps, our software as a service. So there's a few ways you can actually deliver your code to the cloud. If you have something on-premise now, Azure has a portal, and that portal is, I'll show it in a second. And then we have the CLI, which is a command line interface, which allows you to use, to create VMs and use Bash and all the tools that you're familiar with, linked in with the CLI that we have built. It runs on Windows, Mac, and Linux. And we also have these things called ARM templates, which I won't get into in much detail today, but they're sort of a more advanced way to record and deploy things out to the cloud. So as I mentioned, the Azure CLI is the first thing I'm going to show. It's Windows, Mac, Linux, runs on all of those. It has a cool cloud shell, which I'll show you in a minute what that means. It's POSIX Bash compatible, so if you have a big investment in scripts. I saw somebody on Twitter yesterday posted something about it's scary how many people run mission critical operations at their company on Bash, which I hearted and retweeted for sure, because it's true. There's a huge investment generally in Bash, and people generally are looking for something that they can use to take their existing Bash investments and then extend those to the cloud. So I'll show you how to do that. Our CLI is open source, it's on GitHub, and it's extensible. It's based on Python. So let me show you a little bit about what I'm talking about here. So this is the Azure Portal. Okay, this is probably the most logical place for everybody to start if they're working with Azure in the cloud. If I want to create something new, I just say create a resource, and I say Java. I tried this earlier because the Wi-Fi seems to be a bit flaky, but it is, yeah, it's fine. It's no worse than San Francisco here. So in case anyone's wondering, at Java 1 this year, the Moscone Center, San Francisco, the Wi-Fi was pretty slow. This is actually better. So the Java coffee shop. So these are some of the things. So I just went into the portal and I just typed Java in what we call the marketplace, and it brings up everything that has the word Java in it as results. The first thing that comes up is a Java coffee shop, and that's a web app. So we have basically 3 ways to deploy things to Azure. We have virtual machines, which everybody's probably familiar with, Windows or Linux. And then we have software as a service, and that's what I'm talking about here. And then we have containers. So software as a service is what we call web apps. And in this case, if I click here, what it's going to do is it's going to load up a jar file that has a coffee shop application. And it has Tomcat and Java pre-built in a container. It's going to deploy that all out to Azure for me and give me a link to it in my portal so I can start it up right away. The next thing we have here is we have a JRuby image, and when it says compute over here, that means it's a virtual machine. So the JRuby stack's a good example here. It has Tomcat, MySQL, JRuby, Rails, all built in. All the right dependencies are already built into the VM. So you can create that VM. If you have something that runs on JRuby, you can actually just fire up this VM with, it's a template, and you can deploy that out to Azure right away and then just start running your JRuby code on top of it. So that's sort of a pre-made way to do that. There's a couple of other things as well. But for now, let me show you the other things you can do. I mentioned the CLI as well. So pretty much everything you can do in this portal graphically, you can also do through the Azure CLI. And the CLI is a download I mentioned, is Python. If it's in Linux, you get apt-get to get it. If it's on Windows, you just download and install the installer. Mac, you can use Yum and a few other tools to install it as well. But once you install it, you basically get this, which is the Azure CLI. And like I say, everything you can do in the portal, you can do in the CLI as well. So let's say I want to create a virtual machine. I say AZ VM create, and I say -H. It's going to give me all the help for that. So Azure VM create, and it's a little slow to return. There we go. So inside the help there is a huge amount of options here. You can build some really creative and complicated virtual machines, network capabilities, all kinds of things built into it. You can specify a specific image. So I showed you the JRuby image. You can actually say create a VM and use that JRuby image and just build that out for me and then put some code on it. So you can integrate all that into a script, and then inside that you can drop a shell script onto the new VM. And that shell script can run a bunch of commands to get your environment set up on the VM. And you can set up Windows or Linux VMs. We have on Azure, over 40% of our virtual machines are now running Linux. Mostly Ubuntu, but we also have Red Hat, SUSE, and a few other platforms as well. So how many people have heard of our Bash on Windows as well? I'm running a Windows machine, but okay, just one of you. So I showed you the command window, which you would expect the CLI runs in. We also have Bash on Windows on newer versions of Windows now. And the Bash on Windows, you get the same exact functionality, but it's built into Bash. So if you have a shell script that runs on Ubuntu, this is actually an Ubuntu environment here, built into Windows, on the Windows 10, the most recent version, and you can use that there. Now let's say you don't want to install anything on your local machine. You can also use the CLI. Let me go back to the portal. There's this new thing here, which is that little icon fires up, and this might take a little while depending on the speed. This actually fires up a CLI built into the portal. So if I'm running on my local machine, I start up the CLI, the command line. I could be in Bash or I could be on Windows, and I log into my account for Azure. In this case, I don't need to log into the account because the portal's already logged into the account. I'm out on the web now. And this is actually creating a little container, a Docker container, out on the web, and it's going to create a cloud shell for me. And I can do the same thing here. So we have all the Azure commands that you have locally on the Cloud Shell as well. So if you want to create a VM, you want to do anything basically from here, you could do that. There's two limitations with using the Cloud Shell that I've encountered so far. The first one is access to your local file system. You don't have access necessarily because this is on the web. But you can overcome that by loading something into somewhere on the web where it's URL compatible, or putting things on GitHub, or that kind of thing. So basically, if you need to copy a WAR file or something from your local machine out to the cloud, you can do that using the local bash on Windows or the command, or you can put it on GitHub or on file share somewhere and just point to it via URL. If it's on GitHub, you'll say git fetch from here and then pull it in. What else? Oh, the second one is SSH. So you can set up your VMs, and I'll show you an example of this in a minute, to automatically generate an SSH key for you. The SSH key is not stored in the Cloud Shell because there's nowhere to store it. So that's another one to remember. The other thing that's kind of cool about the Cloud Shell is there anyone here using Cloud Foundry? One person? Okay. We also have the Cloud Foundry CLI built into this. Tmux is built into this. What else? Oops. Shouldn't have typed that, actually. What else is in here? There's a bunch of other tools already built into the Cloud Shell that you can use right away. So it's kind of cool. If you have a shell script, you can just grab it and run it here as well. It's completely compatible. And also, I don't have an adapter to show you right now, but there is an Azure app you can get that runs on Android and iPhone, and it actually has this Cloud Shell and all the Portal in it as well. So I can actually use my shell, I can run scripts and things from my phone as well to create VMs and stuff like that. So let me show you. So I mentioned the VMs already. I showed you a little bit. There's many ways to get started. So there's a marketplace, there's a community. Oh, the other thing you can do is you can bring your own image. So if you know how to make a Hyper-V image, a VHD file, virtual hard disk file, you can do that locally or on the cloud. You can actually specify that image. Remember I said you can specify an image. When you deploy the VM using the CLI, you can actually grab that image and create your own image. So let's say you want a JRuby, but you want a very specific version of Tomcat, or you want Netty or Jetty instead of Tomcat or something like that. You can create an image that's ready to go, put that out on Azure storage or in a local file or something, and then use that when you're actually building the VMs. And that's an easy way to deploy those. And I'll get into why you might want to do that in a minute. Okay, so the first demo I want to show you guys is I've already created a VM, and what I wanted to do here is I wanted to create, I wanted to recreate what you might want to do your first application and deploy it to the cloud. So you've got a working application that runs locally, and that's what this is. This is on BEnz and GitHub. It's called Spring Boot To Do. It's a little to-do app. And it basically just allows you to create tasks and mark them as done. Really simple stuff. It's nice. It's a Spring Boot application, so it's a nice example of an application that you can use and deploy using a backend. So in this case, it uses MySQL locally. So what I had to do is I had to change the application to use MySQL on Azure. And Azure actually has a MySQL and Postgres service that you can use. So you can use MySQL locally, or you can change the application properties. And I did that here. The application properties, in this case, it's a Spring Boot application. So you say Spring Data Source, and you put in the JDBC connection string that you're going to use. Then you have an admin name. This isn't the real one, and that's not the real password. But everything else is real, which is the JDBC driver, and then Hibernate DDL. Everything's set up the way I need it. So all I needed to do to change this application from local MySQL to to the cloud was, first of all, I went into the portal. So I go into my portal here. And over here, I created a service called BEmysql. Basically, I'll get rid of that cloud for now. BEmysql is a MySQL database. If I click on connection strings here, it gives me a connection string that you can connect to this database. You also have to whitelist yourself, so you whitelist any IP address. And let's see. Next thing I do, because it's a Spring Boot application, the default port is 8080, so AZVM open port and the name of the actual VM, the name of the group, and then the port I want to open. And then I get a list of the VMs that I just created for this resource group in case there's only one. And then I go to the VM. So I just SSH into that VM. So let's do that now. This is the part that I already did. So let's go to Bash on Windows today. So I can SSH into that VM. There it is. It's up. And then the next thing I want to do, whoops. And by the way, this is called Visual Studio Code. This is a free text editor that you can get. It's vscode.com, I believe it is. And you could actually download it. It's free. And it runs several different scripts. It's a very popular one, over 1 million downloads now. And you can even use, it's the most popular Go editor, for example. Anyone here work with Go by any chance? No? Okay. It's the most popular Go editor that there is. So that's kind of nice. Okay. So the next thing I did after I went into my VM is I did an apt-get update just to make sure I've got the latest version of the operating system. And then I did a sudo apt-get install OpenJDK 8. Does anyone know what that does? Who wants to let me know what that does? It actually installs the OpenJDK because I need to run a Java application on this VM. So it actually creates an OpenJDK image for me. It'll get OpenJDK, the latest version of the JDK 8 for me. The next thing I want to do, and this is another thing I mentioned, one of the limitations of using that Cloud Shell is you can't get files from your local machine. So this is the other thing you need to do from the local machine. In this case, what I do is I just do a list of my files that I already have on my local machine. And because I'm using Bash on Windows, I do a mount, and I do C users BEnz. So this is actually my documents file in Windows. And then under GitHub, Spring Boot to do, and Target. So it'll actually list the files that I have at that location. And oops, can't access it. That's okay. I think there's, yeah, I know why. But I already did this earlier, so that's okay. So the next thing I did was a secure copy. So once I've got the JDK, I've updated the operating system, I got the VM sitting there waiting. Now we want to load the app onto it, so we use SCP. So secure copy. We mount we secure copy from the location that I gave you, just the WAR file, and I copy it to the VM. And then I just check on the VM. Oh, I know why I won't do that, because I'm already logged into the server. So it's looking for the files. If anybody understands what happened there. The reason why it gave me an error is because I'm already SSH'd into the virtual machine. So when I say list, it's looking for documents, which is on my local machine, but I'm not on the local machine. I'm on the virtual machine out in the cloud right now. That's why I wouldn't do it. But if I do a list here, I do get the WAR file that I already copied up to the cloud. And then all I need to do is fire up the WAR file. And let's do that here. Spring Boot app, so it takes a few minutes to start up. But once it's up and running, there's a lot of stuff that happens there, huh? There we go. So it's up and running. All right. So if I click here, It's actually going to fire up the to-do app now on port 8080, which I opened already on the virtual machine. And there's my to-do list. I can add a new task, demo at Devox, Morocco. Let's do 2 X's, not 3, and let's do demo. And when I write this, it's actually writing to my MySQL instance on the cloud, and I can mark that as done, and everything works fine. Now, if I shut this down, because I'm on the server, of course, if I exit that SSH window or shut down the app, it actually closes down the app as well. So now it won't actually work. And that's it. So that's just a demo. So I wanted to show you there just how you can actually deploy something to the cloud. I used only the CLI. That's the only thing I needed to add that's provided by Microsoft. Everything else is tools that you probably already have, that you probably already used. I used Bash, I used SCP, SSH, and a few other things, and it was all from the command line. So it's kind of a cool demo. I'll share the slides, and you can see on GitHub how to do this as well if you want to just try it later. It only takes about half an hour or so to get it started the first time, and that includes signing up for a free trial, stuff like that. So what else can you do? So VM scale sets. Let's say you don't want to just deploy it to one virtual machine. You can use virtual machine scale sets, which we have as well. You can use up to 1,000 virtual machines clustered together by a single front-end IP address. And when you fire up that IP address, you actually deploy to all of those virtual machines. Here's the Azure CLI command for that. It's AZ, instead of VM this time, it's VMSS, so VM scale set. Create, and you use a resource group again, and you say the name that you want to create for the VMs. You specify the image, and you can specify any image. And then you say instance count 1,000, load balancer, blah, blah, blah. Now, that's going to get you 1,000 Linux images. But now, how do you actually get your code onto each one of those Linux images? Right? The easiest way to do that is here. That's what I mentioned before. You can create your own custom VHD files to create for VMs. So you would actually create a VM that's ready to go with all of the files you need in a virtual hard disk file, a VHD file. You'd put that out on Azure Storage or some other place that's accessible by a URL. And then you would say image and give it the name of the image, just like I did in my command here. I have a specific image command. Where's my image? There it is. So in this case, I use the canonical. This is provided by Microsoft, but you can also just use any file that you can get to by URL and download it from a blob. So that's how you would get 1,000 images of your app ready to go in a virtual machine scale set on the cloud. And then you say, standard load balancer and set up a subnet IP address for it as well. The subnet IP address is for security. Scaling. So you don't have to actually create 1,000 VMs right away on a virtual machine scale set. What you can do is you can create it, instead of saying instance count 1,000, you can just say instance count 10. You can have 10 VMs sitting there ready to go, waiting, or 1 or 3 or whatever you want it to be. And then what you do is you set up auto scale. And the auto scale here goes through the portal. You can also set this up through the CLI, but this is just nice and graphic. So the auto scale idea here is the minimum number of VMs you're going to have is 1. Okay? The maximum number of VMs is 10. So between 1 and 10 VMs for this particular VM scale set. Scale out CPU percentage. So if VM1 goes over 75% CPU, add 1 more VM. Okay? If VM2 goes under 25% CPU, close down that VM. And the number of VMs to decrease on scale, so you can add this, you can add it 5 or 10 VMs at a time instead of just 1 VM at a time. So that's another handy tool you can use. So that's the kind of idea with the scale sets that you can use to deploy things. Pretty straightforward. And once again, you use your own custom image, so when you actually create the VMs, it'll use your image. So that's all I want to talk about VMs. The other things I want to show you is some of the things we have with containers. Now, not a lot of you using containers, so I'll just tell you what we have, and you can check into it. We have Azure Container Service. It's open source. It uses regular Docker. We're part of the Azure Open Container Initiative, or sorry, the Open Container Initiative, not Azure, which is IBM, Facebook, a bunch of other large vendors. We're all combining our efforts on building compatible Docker containers and orchestration engines. So the idea here is you can create a container, just like you can create a VM image, and that container can have your application inside it, and it runs on top of the operating system. But how do you actually work out, let's say you have 5 of those containers, you want them all to work together, you need some sort of orchestration engine. And to do that, we have this thing called Azure Container Registry and Azure Container Service that allows you to set up a registry, put some default files on it, and then have those orchestrated by standard industry orchestration engines like Kubernetes, which we just announced actually a preview of a open source Kubernetes service a while ago. Also DCOS, Docker Swarm. All these things are tools that you can use to orchestrate all the containers that you want to use. In general, you wouldn't want to just use one container, especially in production, probably at least 10. So how do you actually make sure that all those containers are running, they've got the latest code on them, that they're talking to each other, that if something happens to one of them, it can be shut down and another one can be created, things like that. That's what the orchestration engines handle. We also have this thing called Service Fabric, which can be used with Windows or Linux. And it goes a little bit beyond the orchestration engines that are provided in the open source world. It actually has management for microservices and containers and puts them together in an easy to manage framework. So you just drop your microservice code onto this thing and it will manage clusters, scaling, and all kinds of things for you. And then of course you can do single container apps in the app service. And I'm going to show you an example of that from Eclipse in a minute. And Service Fabric, I covered that a little bit. So App Service is our software as a service offering. So I showed you virtual machines, then containers. At the other end of the spectrum is web apps, mobile apps, logic apps, and API apps. We actually manage all of the infrastructure and all of the scaling for you. So the idea here is if you have a Java application that you want to run, you just want to run it. You don't want to create a VM. You don't want to choose the operating system. You don't want to do anything. You just got a VM. I've just got a WAR file, and I just want to drop it on a Tomcat server, and I just want it to run. You can use our web app service. We have Windows and Linux container-based app services, and you can literally just drop a WAR file on it. It already has Tomcat running, and you can use that for deploying an application. And I'll show you what that is here. So our app service, which is our software as a service, it runs, you can use .NET, Java, Node, PHP, Python. And as I mentioned, it's auto-patching, it's auto-scale, and it works really well with existing apps, and you can use continuous deployment as well. So app service on Linux. Let me see here. Yeah, I'll go to the portal again. So if I want to create a new app service on Linux, I can say new web and mobile in the portal, web app for containers. And basically I can, there we go. I can create the app and then I can configure a container. So I'm going to create this app service and then we're going to take a container and drop that onto the app service. Okay? There's 3 ways that you can actually get that container onto the app service. You can use Azure Container Registry, which is our own built-in service that you use to privately register any Docker files you have that are pre-configured. You can also use the Docker Hub. The Docker Hub is out on the web. Just search Docker Hub. It has a bunch of standardized images you can use already. Or if you have a private registry, similar to Docker Hub, but you built one yourself for storing your Docker files, as long as it's accessible by URL and you can use a login name and password, you can actually access that from here as well to create your container. So reach out to my private registry, grab a file that I know about, put it on my Linux app service. And the Docker Hub, I'm going to show you as an example, because you can just say something like, I can say Jetty, and over here the little green mark says, yep, there is a Jetty container. And when I say OK, it's actually, it's just going to create that container for me out on the web. So it's going to create a Jetty app server for me in a Linux Linux container, and it's going to drop it on an app service for me, and it's going to tell me when it's done over here in the portal. It takes a few minutes, so we'll get back to that in a little while. But it's really easy to set up your own Linux containers, something that's kind of handy. The other thing you can do, so far what I've showed you is just apps that you already have out there that run by themselves or run on the cloud. The other thing you can do is you can enhance your apps by using some of our app services. So we've got a number of app services, and we built SDKs around them. So the idea here is if you have something in the file system, you can use our Azure Storage and our Azure Storage SDK to use that for the file management that you want to use in your application. Then we have things like Key Vault, which manages secrets and tokens. We have SQL database, of course, and I showed you the Postgres and MySQL services we have too. Data Lake is a Hadoop-based environment with Spark and a bunch of other things all pre-configured. And you basically just plug into that using the SDK. Service Bus, Active Directory, if you want to build security on Azure Active Directory, we have an SDK for that. Cosmos DB is something I'll get into in a bit. Web apps, so you can access those web apps through there as well using Java. So I showed you how you can do it with using the CLI to access, for example, virtual machines. You can also do that writing some Java code if you prefer. And that's something you can build into an application. So the application itself will go out and build a VM using our SDK. And it can put it on a virtual machine, it can put it on a web app, whatever you want to do with that. All right, so the other demo I want to show you is our toolkit for Eclipse. So we've actually built some tools. These are open source. They're on GitHub. They work, there's a plugin for Eclipse and a plugin for IntelliJ. They both work pretty much the same, but I'm going to show you the Eclipse version of this today. So let me get to that real quick. So let's say, how many people here use Eclipse? Okay, quite a few. How about IntelliJ? Even more. Wow. Okay, now that's not normal. Usually there's like a few more that use Eclipse than IntelliJ. That's amazing. But anyway, you can use this same exact example. Once you download the plugins, everything works the same for both. So what I did, this is Eclipse. I created a simple web project, and it basically just says hello. When you click here, it goes out to Azure websites and it says hello. Now, all I had to do for this was to deploy this out to Azure is right-click. Let me just change this a little bit. Hello, Casablanca. So I'll just save that. Now, getting this out to the cloud is basically 2 clicks. If I right-click here, once I've installed the plugins, I get these options down here under Azure. Configure Application Insights, which is our telemetry tool. It's free up to a certain number of users. It's kind of cool. It's basically you take an instrumentation key from the service in the portal, you drop it into your web apps folder in your Java application, and it starts collecting telemetry on the application. Any errors you have, stuff like that. You can also add HTTP filters for activity that's going on between app servers, and a couple of other things. And it automatically builds a dashboard for you on the web. You don't have to worry about the dashboard. It's already built into to Azure. The other option here is add Docker support, and basically that just links into a Docker account that you might be using already. Then I can actually publish this as a Docker container, and I can put it in a VM or a web app. Or a container service, and then I can publish this as an Azure web app, which is I'm gonna do that today because it's the easiest way to go. So when I say publish as a web app, it gives me all the web apps that I have already created in my account. I'm just going to click on this one and say deploy. So that's the 2 clicks. Pick your web app and say deploy. And it'll take a minute. It actually takes a second. Down here you see this little green bar. Once it turns to a published that means it actually published out to the web. It takes a little while. This is not a very good example because this is such a small piece of code, but it actually packages up a whole bunch of things and deploys them out to the web app for you, including container and a few other things. So outbound Wi-Fi is actually really critical at this point, and this is a little bit slow. So I'll come back to this in a minute. Just show you it worked. So while that's running, I did mention Cosmos DB. We have a distributed Cosmos DB application. Let me show you. I did mention regions earlier, Azure regions. So this is kind of interesting. We have a ton of regions. I had somebody at Java 1 just about a month ago ask me, would you guys just rent space from AWS like everyone else? And no, we do not. We have billions of dollars, I'm not kidding, billions of dollars invested in all of these little green dots you see here. Each one of these green dots is at least 3 buildings, and each building is multiple stadiums of size. They're just absolutely massive buildings, and we have racks and racks and racks of servers in each one of those buildings. When you create an image on Azure, even though I just deployed this little application that I showed you there, that Hello Casablanca application, it actually goes on 3 servers in one location. And if we need to update the operating system, it does one of those servers at a time. So you'll never know that anything's being updated or patched or anything like that. You also have options at certain subscription levels to put it in 3 different buildings in that one location. That's why we call them regions and not locations. And then you have options to actually replicate between different locations. And that's what Cosmos DB does, actually. So Cosmos DB is, I think, in 12 of these endpoints around the world. And you can set up a string of data that says, write to Japan, if I'm in Japan, write to the US if I'm in the US. And it will actually merge those reads and writes together really quickly and return results for you. So that's kind of one of the advantages of Cosmos DB. The other one is that we have this thing called data model. So basically, multi-data models are supported. Key value pairs, like Redis, something like that. Documents, including DocumentDB, which is our own platform, and MongoDB. Also, we have a column family, which is like a rows and columns traditional table, but it's schemaless. So each row can have a different number of columns or different values in each column. And we have graphs. So these are some of the APIs that we've already combined. If you have MongoDB, if you're using that in an application, you can just change the connection string and plug it into Cosmos DB. And you've got a much more secure, worldwide, replicated data set that you can use. Also Gremlin Graph and Spark and a few other things. And we have big SLAs for this. So in the interest of time, I won't go do it, but we do make sure that this is very reliable. We have a customer called Jet. Does anybody know Jet.com? No, it's bigger in the US. They have 100 trillion transactions per day. And we actually use this to run our OneNote application and a few other things on Office 365 as well. So that's how it's actually got started. We were using it for Office. And now we sell it to third parties as well. So it's huge, very, very compatible, very powerful platform if you need one for building and scaling your MongoDB applications, for example. Let's see, did this finish? Yes. So this finished now. I'm just going to go back, click on that. Hello, Casablanca. So it just actually deployed out. And I just want to show you it worked. The other thing we have, how many people are interested in serverless, Azure Functions or AWS Lambda? Just 2? Okay, so basically the idea here is you've got these functions, and AWS actually started this with AWS Lambdas, but the idea is you've got this serverless code, and what that means is you write functions on the cloud, and those functions on the cloud can be called by any language. So you can call them from Java, .NET, Python, PHP. So one example that I like to use is, let's say you want to write a photo, and every time you create that photo, you want to have several thumbnails of the photo in different sizes, okay? So you can write an Azure function that has a trigger, and the trigger is, anytime a photo is loaded into my blob storage, run this function and create thumbnails. That's all. It seems like a silly little thing, but it's actually harder than you think to write that in all these different languages if you're using it for different applications. In this case, I would just write something. I could use Java to write something to a blob, and that would trigger the function that actually generates the thumbnails. And some of the triggers you have are things like HTTP requests, timers, storage change, as I mentioned, so I add a picture to storage. And basically the idea here is you've got a trigger. That trigger calls the function. There's an input binding, which you can actually include whatever triggered the function. It could be a picture, it could be some text, things like that. And then you actually run the function, and you have an output binding, which will give you a success or a failure or a bunch of thumbnails. In this case, for my example, that would actually deliver. As I mentioned, multi-languages. So you could run, if you call this function from .NET or Java, it's going to have the same exact functionality. It's going to return the same returns. And you can work with our SDKs to actually write and return values to the functions. It works with Jenkins. It works with a lot of other CI/CD tools as well. And you can develop things locally on Visual Studio Code, which I showed you, or on Eclipse and IntelliJ, and you can use Maven as well, and to actually deploy these. Yes, there's a question there.
Yeah, what do you write the function in?
The functions can be written in several languages: Java, C#, I think Python, PHP, and a few other languages as well. So yeah, you don't have to worry about, like, they're not all written in .NET or C# or if you don't know those languages. We have SDKs to actually call the functions from Java, and then you can write the functions in Java, for example. Yeah. Just real briefly, because we only have a few minutes left, we do have some DevOps tools as well. We have plugins for CI/CD, telemetry, and analytics. And we have this tool called Visual Studio Team Services. How many people have heard of that before? Okay, I'm surprised. There's a couple. I will skip over it though. But the most important thing is it's really good for managing multi-code projects. You can use it for, if you've got a project that has PHP, Python, and Java, you can actually delegate tasks and people can check in code in all those different languages and it'll trigger things like Jenkins. And then for Jenkins, we have storage, ACS plugins, Azure Container Service plugins that you could use to deploy your artifacts from Jenkins out to Azure Storage or Azure Container Service. And we also have distributed builds. The idea behind Jenkins distributed builds is you can have a master process that calls a bunch of distributed processes. Those distributed processes, in this case, we've created a plugin that they can be virtual machines on Azure. So Linux or Windows virtual machines can be called from a Jenkins master process. It can run some things. So let's say you want to do a test on 6 different kinds of Linux and 2 flavors of Windows. You can actually call from a Jenkins master all those virtual machines, which can be in all those different formats, run your code and test it on all those different virtual machine environments, and then have a report back up to the master process if there was a pass or fail on each one of those distributed builds. And I mentioned App Insights for Java as well with the instrumentation key that you can plug into your web apps folder. Oh, cognitive services. Okay, real quick. We got 2 minutes here. Cognitive services is a real reason to use the cloud. It's something you can't really do on your own, but we've actually built some major artificial intelligence, machine learning functionality using languages, speech, vision, search, and knowledge. And I'll show you an example of this. This is a fun one. How many people here have seen Silicon Valley, the HBO series? No? Okay. So you guys will relate to this though. So Silicon Valley has this thing, there it is. So it's a comedy show, and they wanted to build this application that detects food. So you take a picture of food and it would tell you what kind of food it is, right? It's a good idea. But they didn't have enough budget, so they only did hot dogs. So the application only recognizes hot dogs and tells you it's a hot dog or not a hot dog. And it's a joke that goes through the whole series, and it's kind of funny. So anyway, we thought it would be fun to build an application that only detects bacon, or in this case, Kevin Bacon, the actor, right? So, so it would detect actual pieces of bacon, or it will detect Kevin Bacon. And we had to use some pretty serious machine learning to do this, believe it or not, even to do this fun little thing. So I've got some pictures already here. So that's Kevin Bacon's wife, okay? And so that's neither. So let's go for Kevin Bacon. Images. Now this gets kind of interesting because basically, whoops, any image that you load in here should work. Oh no, that's not it. Oh, why didn't it copy? Hold on. No! Okay, hold on. Where'd it go? Oh, great. Good demo, Brian. Bacon. Images. But there's one image that I found the other day. I hope I can find it again. Hold on. It was a really interesting image. Nah, I can't find it. But let me just go for this one. Oh, I know why, because I have to say view image. Okay, hold on. I have to do this. Actually, I have to do this in Firefox because I have to view the image. Hold on. Kevin. Man, what's going on here? Thank you. Kevin Bacon, images. All right. Let's go. Let's see if I can find this image. There it is. This image, for some reason, I didn't make this image, but this is a great image because it has both Kevin Bacon and actual bacon. So I'll put this in here. Okay, it's failed because that's not a URL, yes. But there we go. And let's see what happens. Yeah, it says bacon and Kevin Bacon. So it actually, so what we had to do to build this is it's an app, you built it, and you had to train it with 30 images of Kevin Bacon's face and pieces of bacon. And it already automatically detects these things. So you can see the kind of applications you can do with this. It's kind of cool. And I've got some resources here. I'll share the slides later. And I guess we've got maybe 2 minutes for questions. Any questions there? Okay. I'll put the resources back up in case you guys want to take a picture of that. But I'll be around after too. So I guess we're up for this session. But there's a keynote up next.